Yeah, good morning all. Now I would like to discuss about basics of electrical and electronics engineering. Okay, first of all I will discuss about some basic definitions. First one will be current I. Okay, the current I is nothing but the flow of free electrons through the conductor is known as current. Okay, the units for current will be amperes or coulomb per second. See here already we know that current I is equals to dq by dt, right? That is equals to q by t. Units for charge will be coulombs and units for time will be seconds, right? Then the units for current will be coulomb per second or ampere. Okay, that is about current. Similarly voltage V. Okay, voltage V is nothing but the work done to move a charged particle from one point to another point is known as voltage. Okay, that is voltage V is equals to work done divided by charge. Okay, that is the units for voltage will be volts or the units for work done is joules and the units for charge will be coulombs. Joules per coulomb is also another unit for voltage. Okay, that is about voltage and current. Okay, now let us consider a conductor. Okay, a resistor is a conductor having a resistance R. Okay, this conductor is having free electrons. Okay, now apply a voltage of V volts. Okay, voltage or potential difference minus plus. Now see here, because of this voltage only current I is flowing, right? Now you can understood here. See here, this conductor is having free electrons but there is no movement. Okay, the flow of free electrons because of this presence of the voltage only. Okay, the flow of free electrons is nothing but current. Okay, the force which is required to produce this current is nothing but voltage. Okay, that is about voltage and current or see here in this circuit, without this voltage there is no work done, right? That means the voltage is nothing but work done to move this charge or charged particles in any circuit is nothing but voltage. Okay, that is about current I and voltage V. Okay, next power P. Okay, the rate of doing work is called power. Okay, that means power P is equals to work done divided by time. That is power P is equals to work done indicated by W and time indicated by T. W by T, W, that is W is equals to, from this equation, work done is equals to voltage into charge, right? Then V into Q divided by T. Okay, then power P is equals to V into, already we know that Q is equals to I into T from this equation. Okay, that is V into I into T by T. Then power P is equals to V into I units. Okay, the units for power will be watts. Okay, but from Ohm's law, voltage V is equals to I into R. You can remember this formula, I will explain Ohm's law later. Okay, that means power equation is power P is equals to V into I, right? If I substitute V is equals to I into R, I will get power equation as I square into R. Okay, from this formula I equals to V by R. If I substitute I value here, I will get power P is equals to V square by R. That means power equation is power P is equals to V into I or R, V square by R or R, I square into R. That is about power. Next, energy E. Okay, the capacity of charged body to do work is known as energy. Okay, energy E is equals to power into time. See here, power into time, already we know that power P is nothing but V into I into time, that is equals to I square R into T, that is equals to V square by R into T. The units for energy will be watt hour or kilowatt hour. Okay, that is about some basic definitions. Okay, now we will discuss about Ohm's law and its limitations. Okay, see here, this is the statement of Ohm's law. Okay, at a constant temperature, the current flowing through the conductor is directly proportional to the potential difference or voltage. Okay, let us consider a conductor. Here resistance R is a conductor. Okay, and apply a battery voltage of V volts. Okay, minus plus. Current will flows always flows from higher potential to lower potential, that is positive terminal of the battery to negative terminal of the battery. Okay, now see here, because of this voltage what happened, current I is flowing into the conductor. Okay, the statement, the Ohm's law states that at a constant temperature, remember this point is important, at a constant temperature the current flowing through the conductor, is directly proportional to potential difference or voltage. From that equation, V is directly proportional to I. If I remove that proportionality constant, V is equals to I into R. Okay, where R is proportionality constant, or R is the resistance or resistor R. Okay, now coming to limitations. Ohm's law cannot be applicable to non-linear devices. Okay, Ohm's law cannot be applicable to non-linear devices like diodes, transistors. Okay, example, Ohm's law cannot be applicable when temperature changes. Okay, next, Ohm's law cannot be applicable to semiconductors, that means that is also comes under non-linear only. Okay, Ohm's law cannot be applicable to vacuum tubes. Okay, those are the limitations of Ohm's law. Okay, next coming to resistor or resistance R, which opposes flow of electron through the conductor. Okay, which is denoted by resistance R. Okay, here it is the symbol of resistor R. Okay, the units for resistance will be ohm. Okay, now see here the factors affecting resistance. Okay, the resistance of a conductor is directly proportional to its length. Okay, that means if length of the conductor is increases, the resistance is also increases. If length of the conductor is reduces, then the resistance of the conductor is also reduces. That is the meaning of this point. Okay, next one is the resistance of a conductor is inversely proportional to the area of cross section. Okay, the resistance of a conductor is inversely proportional to the area of cross section. Okay, when area of cross section is more, then the resistance offered by the conductor is less. If area of cross section is less, the resistance offered by the conductor is more. Okay, that will give this point, that relation will give this point. Okay, next, the resistance of a conductor depends upon the type of material, right? Every material having its own resistance. Okay, copper is having some different resistance, aluminum is having some different resistance. Okay, silver is having some different resistor, right? That means the resistance of a conductor depends upon the type of material. Okay, next, the resistance of the conductor depends on the temperature. Okay, the resistance of the conductor depends upon the temperature. Okay, now from equation 1 and 2, the resistance is R is directly proportional to L by A, that is R is equals to rho L by A. Okay, where rho is specific resistance or resistivity. Okay, that is about resistance. Okay, what is my resistance? Which opposes flow of electric current. Okay, to understand about resistance, let us draw the resistance symbol R and apply a battery voltage of 5 volts. I am considering resistance value as 1 ohm. Okay, now because of this potential difference, current I is flowing into the circuit, right? Then current I is equals to, already we know Ohm's law, right? From Ohm's law, V is equals to IR, then I is equals to V by R, right? That is I is equals to 5 by 1, current is 5 amperes. Next case, I am changing resistance value to 1000, then current I is equals to V by R, right? 5 by 1000. That means 0.005 amperes. Okay, suppose if resistance value is 0, current is infinite, right? 1 by 0. If resistance value is 0, then current I equals to 5 by 0 infinite. If resistance value will be infinite, current is 5 by infinite 0. Okay, from all those from all these four results, see here, what is the definition of resistor? Which opposes flow of electric current. Opposes. See here, first case I am assuming resistance value is 1 ohm. This value is less, right? Then it will allow more current. Next case, resistance increases to 1000 ohms. When resistance value is high, what about current? Low. When resistance value is 0, current is infinite. Very dangerous amount of current is flowing through that resistance, right? When resistance is infinite, current is 0. No current is flowing through the resistor, right? That means always current to choose low resistance path. When resistance is low, current is high. When resistance is high, current is low. Okay, that is about resistor. Okay, remaining we will discuss in next class. Thank you all.